Okay, my name is Mae Culumber. I am a nut crop advisor, and I'm based in Fresno County. And we've been working with Cameron and a number of other people for the last several years. Looking at this method of orchard recycling and trying to figure out what the impacts are for potential differences in how we might manage orchards, and now a lot of people I know are looking into what the effects of doing this might have on other crops, field crops or other perennial crops. So the big question, and Cameron really did a great job of setting this up, is can we return this large amount of organic material back to the soil without negatively impacting the next crop? And the reason, so we've been doing a lot of these different surveys throughout the state. So we've got about 9 active sites where we've been looking at the effects of doing this recycling at different rates. Depending on what the previous crop was, there might be different rates. We found that mature stone fruit orchard might add about 30 tons of dry weight material, whereas a 25-year-old almond orchard might be more on the level of 60 or maybe sometimes even 80 tons. I'm thinking of like Butte Padre, gigantic orchards, and walnut orchards even more so. And so these all happen to be recycled almond sites, but we're looking at things. Cameron mentioned carbon. We're trying to track, trying to put a number on what is that carbon storage. How much is blown off in the form of CO2 from microbes. Turning this material over, and so what are the long-term implications for storage in the ground, at least through the lifetime of the next crop? And looking at that in different soil types, different climates. We're trying, for the growers from a practical perspective, trying to figure out what's the optimal amount of nitrogen that's going to be needed for tree growth, to get adequate nutrition, and ultimately to get you the satisfactory or even better yields. And then, as Cameron mentioned, we're looking to characterize the changes in potential changes in orchard water use as well. So to put some perspective on how much, 60 tons, which was what we think the average would be for, a mature almond orchard, 60 tons of dry weight material. I mean, you saw the pictures. I mean, it just looks like an enormous amount of stuff that you're putting out there, and you think it's really going to impact the next crop. But if you think about how deep this is incorporated, and Cameron mentioned, it can be anywhere from 6 inches to a foot, depending on, the order that you do things, the process of recycling, and that all those things can impact the incorporation. But when we've gone back to the field in orchards and dug some pits of a known volume, most of these chips are in the top 6 inches after disking. That's where most of this is. And so it seems like a lot, but when you think about the mass of soil that you have there, I mean, depending on the bulk density, I mean, you're looking at 2 million pounds of soil. We're putting about 120,000 pounds of material in. So it makes up about 6% in that top 6 inches of the material that's there. So relative to the amount of soil, I mean, it's more than a sprinkling, but it's not as much as we sometimes may think. And so the big question is there going to be enough available N for whatever I'm planting next, because this stuff has such a high carbon to nitrogen ratio. So when we've done analysis of the materials and looked at the carbon content, the nitrogen content, other nutrients of this material that we're putting in, we find that there's a ratio, a C to N, of about 160 to 1. So that's a pretty big difference, from what we understand of, how, the prime conditions for microbes to turn things over in the soil, they like things to be about 20 to 1. So that's really kind of the big question. And so, so microbes, they thrive on this carbon, but they do need a bit of nitrogen. And so because that ratio is so, unbalanced, initially when you put this in, nitrogen is going to get immobilized by those microbes, and it's not going to be available for plants for uptake. But we do know that over time that there's going to be a shift from this immobilization to what we call mineralization, when maybe there's a shift in the population of those microbes, and a lot of that initial population dies off. Well, then the dead bodies of those microbes become mineralized, and they release all that nitrogen that they took into the soil. So this change in the microbial community, the decomposition of the wood chips, eventually that's going to start producing nitrogen. But how long does this process take? And so that's kind of the big question. And I'll just start off by saying we have tried to look at decomposition rates of the wood chips in the soil. Cameron built this great shaker sieve table that separates wood chips by different size fractions. And this is just kind of an overall summary of what we found with the biomass over time. So, if you're starting we had a very controlled experiment where we started with a 60 ton per acre rate, and we've looked at decomposition over time. And this blue line, it represents cores of a known volume that we took in the alleyway. And so where we're not applying water, we're tending to see that the degradation rate is much slower. But then in the berm, where our tree roots are active and we're applying water and fertilizer on a regular basis, the decomposition has been very rapid. And I think a lot of times now with some of these trials that we have that are 4 or 5 years old, we'll do the soil sampling in the berm, and you may not even be like, wait, are we in the right treatment? I'm not even seeing wood chips, they're gone. So we're finding that this process happens very quickly, especially in the areas where we're irrigating. Over the years that we've been working with this and talking with growers, a lot of them are saying, when we first get things planted, I'm doubling my nitrogen. And we've worked closely with some growers that doubled their rate of nitrogen, or maybe even sometimes more. There hasn't been a lot of work done with this yet in other crops, but this is just, a table would just show, what the average might be for a first year or an annual planting with the range of nitrogen and what double of that amount would be. So I can't really speak to, I think that there could be some different circumstances with field crops or things where you're seeding directly into this. It's a little bit different than putting a tree in that has a developed root system with how well this overcomes it. So it's an area of research that, with the changing, crops that we're seeing on the landscape and in response to water availability and things like that, it's something that we need more research. But how important is timing and placement? And might that even be more important than the actual rate of nitrogen? And that's what some of the research I'm going to talk about is kind of pointing to being a bit more important. And then with regards to nitrogen, we want to do the best we can to figure out what that ideal rate is so that we can prevent losses. Cameron mentioned will these systems be more or less susceptible to leaching, depending on what type of fertilizer we're using. We might be worried about losing it through volatilization. A big one with the orchard recycling that is potentially maybe a trade-off with putting all this in the ground is that in these real carbon-rich environments, we tend to see higher rates of denitrification. And so a byproduct of that denitrification product, or of denitrification process, is N2O, nitrous oxide emissions. So nitrous oxide is a very potent greenhouse gas, much more so than carbon dioxide. And then importantly, I'm sure you're all very well aware of the cost of fertilizers right now. So this gray line shows what the 5-year average was, from 2022 going back, to about 2018. This was the monthly change in the cost of fertilizers, and then what we saw in 2021 and prices in 2022. So far this year, couldn't get a more updated graph on this. We're seeing, the prices are down a bit from last year, but still way above the 5-year average. So with the price of almonds and other crops right now, it's important that we're fine-tuning these nitrogen rates to the best of our ability. So we've done some small rate trials that kind of back in the beginning of me working with Brent Holtz and Cameron on this, where we were applying granular triple 15 ringing around these young trees, and then comparing them with ones that didn't get fertilizer until about after the first 6 to 8 weeks of growth, which is probably pretty typical for a newly planted orchard if you got the trees in January or February. And we saw, I'm not going to show the nutrition or growth data with these, but just the pictures kind of speak for themselves, where we're seeing that, just a small application of N at planting, ringed so that it's, the tree roots are directly accessing that. We saw, a really big improvement in the establishment of trees going into this, 60 ton per acre wood chip rate. So, looking at that preliminary work that we did, we in 2019 put in a big trial at Kearney Research Station where we're looking at different nitrogen levels. We've got the current UC recommended standard as the middle treatment, and then we have a lower rate and a higher rate. And so there's 150 trees per acre, so that just kind of gives you some perspective, because these rates would change depending on the planting. So it's like maybe a little bit more densely planted than a lot of commercial orchards. But to overcome that nutrient immobilizing carbon and nitrogen ratio at planting, so instead of doubling our nitrogen, we did those initial fertilizations applying NPK as triple 15 beginning in that first week of March. And then through the rest of the course of the season, nitrogen was applied as a UAN and a combination with ammonium sulfate through July of each year. So I know a lot of growers typically try to get a lot of their N on before the end of May, but our approach is to make smaller applications through kernel fill and hull split. So what have been the results, the initial results? Well, in that first year, so we applied, this was this rate, 46 pounds per acre, is the equivalent of about 5 ounces of N per tree total for that first year. So the recommendation right now is 3 to 4 ounces per tree in that first year. So nowhere close to doubling, And when we took trunk growth at the end of the season, we actually found that our wood chip trees were actually larger than the control. And so that mineralization process that I was talking about already appears to be happening in the first season, and we think that application of targeting the root zone with that triple 15 to sort of get that process going appears to be really key. So timing and placement are kind of what we're walking away with here, and we don't need to be thinking about doubling nitrogen rates. And then just to go on looking at yield, 2021 in this trial was the first year where we collected yield data. We haven't seen a nitrogen rate effect yet for our controls or our orchard recycled treatments. The other treatment that I haven't talked about is where we actually are doing an annual application of about 8 tons per acre to some trees, just doing an annual application as a mulch, but we're using a Northwest tiller to till in and like those chips into about the top 2 inches. So those trees have actually performed really well. So as of yet, no statistical difference between the high, the middle, and the low treatment for nitrogen in any of the treatments. And so again, this middle treatment would be close to what the UC recommendation would be. And then why could that be? So I mentioned that rapid mineralization. We're also looking at soil carbon and nitrogen levels. And so we're sampling both in the drip line where the water and the nutrients are being applied, and then in the alleyway as a comparison. So these blue lines here are our control treatments where there's no wood chips applied. And this is carbon on the left and nitrogen on the graph on the right. And then these orange are the orchard recycling. And so in a very short period of time, we're actually seeing significantly higher levels of organic carbon in the soil. And this isn't in the form of wood chips. All of these soil samples, all of that's sieved out for the analysis. So this is, this is organic carbon that's in the soil matrix. And then we're also seeing significantly higher levels of total nitrogen. And so we're looking at a whole number of different things to understand, more about the type and the form and the availability. But in a nutshell, what we're seeing is higher nitrogen levels in response to this recycling. And these values are shown for the control and orchard recycled plots at the middle rate, so same rate of nitrogen. And then we've also been working with some commercial growers to follow what they're doing, because not everybody is doing a very controlled experiment. And so I'll show a little bit, probably already talking for a long time, but I'll show some data about what the fertilization patterns were with this commercial grower. But he basically more than doubled his nitrogen in that first year, but then went 5 minutes, okay. But then went to just a regular fertility plan, maybe even under fertilizing trees a bit in that second year because they had put on so much N. I don't have the tree growth here, but the tree growth was the same from the beginning between the conventional and the orchard recycling. And then we have Monterey and nonpareil yields have been neck and neck, no difference between the control and the orchard recycling. With trees planted in orchard recycling, the rules are kind of the same. We want to do the right rate, right time, right place. So, there's really where the rules change is in that first year is getting that, getting fertilizer on like soon after planting and trying to target it at the root zone. But after that, we wanted to try to target uptake from this mid-leaf out up until that full hull split stage when we know that the trees are actively taking up nitrogen. And so we still recommend that standard 20-30-30-20 approach. There's been a number of studies looking at fertigation in terms of what the impacts are on nitrogen losses. So I touched on earlier trying to reduce nitrate leaching and the nitrous oxide. And other studies have found that the high frequency, short duration fertilizer applications does the best job at maintaining nitrogen in that effective root zone where most of your tree roots are that are taking up the nutrients. So I mentioned earlier nitrification, denitrification. So the problem with orchard recycling is that we put all this carbon into the system, and when we apply fertilizer, we're more susceptible for these nitrous oxide losses. So this is some nitrous oxide data that we've collected both at a commercial grower site that I mentioned and with our controlled site. We estimated that he had about a 45 ton per acre rate in that commercial orchard. And his nitrogen applications were generally speaking in really large doses, especially as the trees have grown, sometimes as much as 40 pounds per acre in a single application. And he gets everything on between March and before the probably middle of May, end of May. These orange lines are the nitrous oxide peaks that we're seeing in those orchard recycled treatments. And you can't see the controls very well, but they're also a blue line in here. Tended to be much smaller actually from the beginning. With this trial, with the 60 tons that I mentioned, we've been doing much smaller N applications and more frequent from March through July. And this treatment, we saw these big spikes in the nitrous oxide in the beginning. Even despite doing maybe smaller applications, it has more carbon. There was a larger application of wood chips. I don't know what we can do to get around that in the first year so much, but I think in the following years, that's when we might benefit from that. So this is another way of looking sort of at the same data, but this line on the graph shows how much nitrogen was applied compared to what we call the emission factor. So the emission factor is the amount of nitrogen in N2O that's lost in proportion to the units applied. And so in both cases, like we see, higher, I mean, it's elevated in the control too in that first year. You figure you've just turned over all of this soil, there's active decomposition going regardless of whether or not it was the orchard recycling or the control. So we see big peaks in both locations where we've looked at this. But then after that, even though we're increasing our N inputs, we're seeing a better efficiency factor in the years after. So it's really that first year that we think is really kind of the most critical. Some good news is that, like other studies so far, our research into this greenhouse gas shows that almonds have a low greenhouse gas emissions relative to other crops in terms of their yield. So with our conventional almonds, we found losses on the level of 0.3 kilograms equivalent per kernel produced, and so that agrees with this review produced of these other studies that happened in California. So it's right there with it. With the orchard recycling, it's higher, but still lower than these other crops. So almonds planted after orchard recycling, they have higher emissions, but it's still small relative to other crops, and we're continuing to look at that. So in summary, orchard recycling has shown no adverse impacts for growth and productivity in replanted almonds, but our data is still limited for other perennial crops and row crops, so hopefully in the future we'll be able to look at some of those things. Fertilizer timing and placement seems to be the most critical factor to overcome that high carbon to nitrogen ratio, and these elevated nitrogen rates do not seem to be necessary. Wood chip decomposition in that wetted area is really rapid, and so that leads to higher carbon and nitrogen levels. Soil health benefits, increasing the fertility of the native soil. And these climate impacting greenhouse gases like nitrous oxide and leaching losses can potentially be reduced with high frequency, low dose applications of nitrate-based fertilizers. Didn't get a chance to get too much into that, but nitrate-based fertilizers, we're going to tend to see lower losses than ammonia-based and urea fertilizers. So, okay, that's all. Thanks.
You don't have time for questions.
Yeah, sorry about that.
Yeah, that's all right. As an organizer, I took all my time. So don't feel